Hello, pre-calculus students. In the past, you've learned about how to solve linear equalities. In other words, systems of linear equations. We graph the lines, see where they intersect. In this lesson, we're going to review, and it should be review for you, how to solve systems of linear inequalities. So you'll notice that I have on the screen here a system of linear inequalities. It's a system because there's more than one inequality, and they're inequalities because they have a greater than or a less than sign in them. Sure, there's an equal, but it's still an inequality. And there are three steps to solving these. Number one, you graph the boundaries. The boundaries are just the lines, so you replace the greater than or equal or the less than or equal sign with just an equal sign and graph the lines. You graph a solid line if there's an equal sign in here, as there is, and you used dashed lines if there's no equal sign. So 5x minus 3y equals 0. Again, this is considered a standard form of a line. The simplest way to graph it is to plot the two intercepts. Set x equal to 0, solve for y, and you get y equals 0. And then set y equal to 0 and solve for x, and you get 0. Well, since it goes through the origin, that's not going to be a big help. We need to pick one more point. And it looks like I chose x equals 3, y equals 5 to get this point. Then I graphed it with a solid line. Here, set x equal to 0, solve for y, and you get a positive, looks like 3 4/5. Yes. And then set y equals 0, solve for x, and you get negative 8.5. Solid line, there you go. So the first step is just to graph the boundaries. The second step is to shade the appropriate half plane. Now this line here divides the plane in half. You have the part down here and the part up here. This orange line divides the plane. You have the parts down here, the parts up here. Shade the appropriate half plane. 5x minus 3y is greater than or equal to 0. So here's this line. Where do we shade? Well, the easiest method is usually just to substitute 0, 0 in and see which side of the line it's on. If it's on the, if 0, 0 satisfies this inequality, then you shade the side of the line that 0, 0 is on. Problem is 0, 0 is on this line, so pick 1, 0. 5 minus 3 is greater than 0, so 1, 0 is right here. So 1, 0 satisfies this inequality. It must be on the correct half plane. So that's where I shaded in yellow. And what we can do here is we can go to the Desmos. And here's 5x minus 3y is greater than 0. And I activate it. And again, 1, 0 is right here. 1, 0 satisfies the inequality, so I shade the entire half plane that contains 1, 0. Now the next equation was negative 2x plus 5y is less than or equal to 19. So I graph that line, and then I check 0, 0, and 0 plus 0 is less than 19. So I shade this half down here below below the line because 0, 0 is below the line. Now where both of those half planes intersect, in other words, this region, there in that bottom right corner, that is my solution set where both inequalities are true. Now, just for giggles, You can actually, Desmos will actually graph dashed lines. You see if I change this to just less than, it does graph the dashed line there, which is kind of cool. So in a system of linear inequalities, recall, there are 3 steps. Those 3 steps are to graph the boundaries, which are just the lines. You just change whatever sign you get to equals. Keeping in mind that you graph it as a solid line if there is an equal sign in the inequality. You use dashed lines if there's not an equal sign. And those 2 lines become your boundaries. Shade the appropriate half planes by using a checkpoint. I used 1, 0 because this one went through 0, 0, and then 0, 0 through the other. And then the area where both of them is true is down here. X is greater than 1 is this dashed line here, and I shade to the right. Now, I'm going to show you some notation here that I use. This is clearly not the purely perfect mathematical way of doing things, but I think it keeps the paper a little bit cleaner and easier to understand. Oh, Mr. Friedman came in to visit. Haven't seen him since March, I think. So anyway, back to the lesson. I expect that you know how to graph these. So X is greater than 1. I graph the boundary X equals 1. Notice it's dashed because there's no equal sign. And then I just draw these little arrows, to the right, meaning anything to the right. Y is greater than 2. Here's my boundary, Y equals 2. Y is greater than 2 is anything above that. Now here's the part where I sometimes think students don't fully understand what they're doing at this part, so please pay attention. Y is less than negative X plus 5. Here's negative X plus 5. Less than means, so let's see, if X is 0, Y is 5. So if X is 0, Y is any number less than 5. Too many times students, come out here perpendicular to it. That's not what less than means. Less than means straight down. So if X is 0, Y is less than 5. So it's anything along this line. If X is 1, Y is anything less than 4. So you notice that my lines go either up and down or right, or if there was anything to the left, because that's what less than means. Greater than means either to the right if it's an X or above if it's a Y. Less than means below if it's a Y, above if it's an X. So I'm shading straight below. Now, where do these 3 dashed lines intersect? Well, they intersect here, here, and here. How can you tell the points of intersection? Well, you know that this is X equals 1, this is Y equals 2, so that's got to be 1, 2. This is X equals 1, this is Y equals negative X plus 5. Use your substitution or your elimination that we've gone over in the past to get this intersection point and this one. Now these 3 points are not they're not part of the solution because the lines themselves are not part of the solution, just the area inside that triangle. So we do have some other situations. For instance, this is page 512 of our current textbook. This has no solution. This one inequality, graph this area up here, one inequality, graph this area down here. These lines are parallel, so there's never going to be any overlap. There's no place where both of these inequalities is true. There is no solution. Then you have this situation where You have this line, and the solution set is anything in here, it goes on forever. This is called an unbounded solution set. Now, what we're hoping for, and this is really important for our next lesson, is we're hoping that our inequalities will graph a convex polygonal region, like a triangle. Convex means if you take, I'm not giving you the official definition, I don't think, but this will work for you. It's a good description. If you take every angle of your region, like let's pick this angle, and so this is my region that I'm looking at, this four-sided region. If I take every angle and extend the sides, is the entire region included in that angle? And is it included in every angle? And in this problem, yes, it is. Now, this is one of the few times where I'm going to give a no to a Star Trek symbol. I've graphed this Star Trek symbol, and you can see that here is an angle where the entire shape is not included in the angle. That's concave, and we don't like that. What we're going to do in our next lesson is called linear programming. We're going to graph multiple inequalities, find hopefully the convex polygonal region that, that satisfies all those inequalities, and then we're going to be able to maximize or minimize a function within that region. So that's it for linear inequalities. Let's see, where am I? There I am. Have a great day.